For each of 5 through 21, prove each statement that is true and find a counterexample for each statement that is false. Assume all sets are subsets of a universal set. Now, for all sets A and B, if A is a subset of B, then the power set of A is a subset of the power set of B. So let's start by assuming that A is a subset of B. Now we want to show that the power set of A is a subset of the power set of B. The way we show that any set is a subset of another set is we start by instantiating an arbitrary element in the first set. So let X, and I'm going to say capital X here, be an element of the power set of A. Now, the reason I use capital X here is because if we use lowercase x, we're usually denoting an element. And X is an element, so that's not wrong. But the thing about power sets is the elements themselves are subsets, and subsets are themselves sets. So even though X is an element of the power set of A, it's also true that X itself is a set. And that's why we'll use capital letters for X here. And so that means that by the definition of the power set, X is a subset of A. Now we want to show X is in the power set of B. So at the very, very end here, we want to say X is an element of the power set of B. But to show that X is an element of the power set of B, we must conclude somehow that X is a subset of B. So this is really what we want to show right now, is that X is a subset of B. We're going to use an element proof to prove this. So let's let lowercase x be an element of capital X. We want to show that lowercase x must be an element of B. So since capital X is a subset of A and lowercase x is an element of capital X, then by definition of subset, that means lowercase x is an element of A. But A is a subset of B. But since X is an element of A and A is a subset of B, then by definition of subset, X is an element of B. And therefore, we've shown that every element in X must also be in B. So therefore, capital X is actually a subset of B. This just means capital X is an element of the power set of B, since capital X is a subset of B. And that's what we ultimately wanted to show. We started with an arbitrary element of the power set of A, and we showed that element must be, therefore, in the power set of B. But this proof is pretty tricky because we had to do an element proof within an element proof. And that's weird. So thanks, everyone, and I'll see you in the next video.